All right. Welcome to the second lesson for geometry. Today we're going to talk about angles and rays. Today's goal is to use the angle addition postulate to find missing angle measures. Let's start by going back to that line that we were talking about last lesson. So we talked about what a line is, and we talked about what a segment is. Today we're going to get introduced to what a ray is. So a ray has one endpoint and then continues forever in one direction. So when you name a ray, the first letter tells you what the endpoint is, and the second letter tells you the direction you're shooting through. So where a line or a segment, the order of the points did not matter, the order that you put the letters. With a ray, the order makes a difference. You always need to put what's the endpoint first, and then what point it shoots through second, and then you always draw a line above it, an arrow above it, pointing to the right. So for this first one, PQ. So just like it says, P is the endpoint, that's where it stops, and then it shoots forever through Q. So that's the ray PQ. So the second one, notice it's the same letters, but now I flipped them. I put the Q first, so this is saying it ends at Q, and now it shoots through P. So notice same letters, but now it's shooting the other direction. So here's the endpoint, and it shoots through P. And then my last one here is PR. So ends at P, but shoots through R. And notice ray PR and ray PQ are actually the same ray. So that was two ways of naming that same ray. Opposite rays. So here's a little definition. Two rays that share an endpoint and travel opposite directions. So QP, so again, endpoint Q but shoots through P, is that ray. And then QR, so it starts at Q but it shoots through R the other direction. And notice the two opposite rays, they make a line. All right, angle basics. So here we have an angle. So an angle is two rays basically that share a endpoint. So we have what we call the interior of an angle, which is all that stuff. That's the interior. We have the exterior of the angle, which is everything else. We have the vertex, which is right here. That's the pointy part of the angle. That's the vertex. So the vertex is B. Point B is the vertex. It's where the two rays connect. And lastly, naming an angle. So there's multiple ways you can name this angle. One way is you can name an angle by just its vertex. So angle B. Another way is to use three letters. So A, B, C, or you could call it C, B, A. The important thing when you're naming is the vertex has to be the middle letter. So you start at one of the ends and you basically trace the angle. So A, grab my hand, so A, B, C, or C, B, A. And lastly, to name an angle, sometimes they'll put a little number inside the angle, and they will call it angle 1. So those are the different ways to name an angle. Classifying angles. So we have an acute angle, which is an angle which is less than 90 degrees. So it's not open very much. It's a smaller angle. We call that acute angle. We have a right angle. A right angle equals 90 degrees. And in a picture, if it's a right angle, we put a little box in there to show that it is a perfect right angle. That's what the box means. It's a 90-degree angle. Obtuse is if you open up past 90 degrees, so it's a big angle. And then the last one is a straight angle, which equals 180 degrees. A straight angle, notice, is a pair of opposite rays. Or it also forms a line. Mr. Larson's $1 million idea, they make socks with a big angle, an obtuse angle, big angle, obtuse, but your foot is 90 degrees. So I think they should make socks at 90 degrees to make them extra comfortable. That's a Mr. Larson $1 million idea. Feel free to run with it. So the first thing we need to be able to do is classify angles. All right, so we got to be able to identify what angle is AFD, and then we're going to classify it as either acute, obtuse, right, or a straight angle. All right, so AFD. So in the picture, we got to be able to find that. AFD. So do people see the angle we're talking about here? From A to F to D. All right. So looking at that angle is bigger than 90 degrees. So we call that an obtuse. Obtuse angle. CFE. 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 So that's this angle right here, CFE. All right. That's less than 90 degrees. It's a smaller angle, so that one is acute. Angle BFC. BFC. So this one we see that it's got the little box in that angle. So we know this is a right angle. It's 90 degrees. So this is a right angle. And the last one, AFE. AFE. Notice that just makes a straight line. That's 180 degrees. A straight line is 180 degrees, a straight angle. All right, the angle addition postulate. You'll notice it's very similar to the segment addition postulate. So what it states, so it says if S is in the interior of angle PQR. So let's kind of take a look at that first. So angle PQR, right? So this angle right here, S is in the interior. So remember, everything in here is interior. So if S is in the interior, then the measure of angle PQS. So let's look at what PQS is. PQS. So the top angle plus the measure of angle SQR. SQR. So the bottom piece, so the top piece plus the bottom piece equals the measure of angle PQR. PQR, the whole thing, right? So just like the segment addition postulate, it is the part plus the part equals the whole. The part plus the part equals the whole. And again, this seems so obvious, and this is why we call it a postulate. So this hasn't been proven. It probably can't be proven that this is true. It's too much of a basic fact, but it is so obvious that we know that it's true. That's what a postulate is. It's so obvious we know that it's true. The part plus the part equals the whole thing. All right, so let's take a look at some examples of that. So I'm going to give it to you in words, and what we need to do is we need to take that, we got to convert it into a picture, and then we're going to solve it. Okay, so D is in the interior of angle ABC. The measure of angle ABD equals 37 degrees, and the measure of angle ABC equals 58 degrees. Find the measure of angle DBC. So reading that, it seems kind of complicated, but let's draw a picture of it. So it says D is in the interior of angle ABC. So I'm going to draw that angle first. So we have angle A, B, C, and notice B is the middle, so it has to be the vertex, right? D is in the interior somewhere, so it's inside. There's D. And then you connect B and D. So there's our picture. Now I'm going to start labeling it. AB, the measure of angle ABD equals 37 degrees. So ABD, that's the top, is 37 degrees. The measure of angle ABC equals 58 degrees. Find the measure of angle DBC. DBC, the bottom. I don't know that. I'll call that X. So remember, the angle addition postulate is the part plus the part equals the whole. The part plus the part equals the whole. So 37 plus X equals 58. All right, solve for X. So we're going to minus 37 minus 37. And we get X equals 21. Now, that's what X equals, but again, I want to write my final answer out with what they're actually asking. So the measure of angle DBC equals X, and X is 21, so it equals 21 degrees. Z is in the interior of angle WXY. The measure of angle WXZ is 23 degrees. The measure of angle ZXY is 48 degrees. Find the measure of angle WXY. Okay, so again, let's start by drawing a picture. So first, I'm going to draw that angle. So W, X, Y. Yes, Y. And Z is in the interior somewhere. Connect X and Z. All right, now I'm going to start doing my labeling. So the measure of angle WXZ, so WXZ, that's the top, is 23 degrees. And the measure of angle ZXY, so the bottom angle is 48 degrees. Find the measure of angle WXY. Find the whole thing, right? Well, I don't know what the whole thing is. I'll put a question mark since there's already an X in this problem. So the part plus the part equals the whole, right? The part plus the part equals the whole thing, which I don't know right now. But if all I have to do is add those together, and I would get 71 equals that big angle. So then I can write my final answer out. The measure of angle WXY equals 71 degrees. So notice here I just had to add the numbers together, and here I had to do some subtraction, right? I had to do a little algebra over here. So make sure you're paying attention to, do they give you the two pieces and you're trying to find the whole, or do they give you a piece and the whole and you're looking for the other piece? For this next one, I'm just going to pop them both up here. So go ahead, hit pause, use your notebook, and go ahead and see if you can solve these two problems. Accurately draw the picture and solve it, and then hit play and check your work. All right, so H is in the interior of angle EFG. So let's draw that first. Angle EFG. E. I'm going to get a little F. G. And H is in the interior. H is somewhere in the interior. There's H. All right. The measure of angle HFG, so that's the bottom piece here, is 17. The measure of EFG, that's the whole thing, is 39. I'm looking for EFH. I'm looking for this top piece. All right, so the part plus the part equals the whole. The part plus the part equals the whole. So X plus 17 equals 39. Subtract 17. X equals 22. So the measure of angle EFH equals 22 degrees. M is in the interior of angle JKL. All right, so let's draw that. JKL. M is in the interior somewhere. All right. The measure of angle JKM is 43 degrees. The measure of angle MKL is 51 degrees. Find the measure of JKL. That's the whole thing, right? I don't know that. So the part plus the part equals the whole. So 43 plus 51 equals x. And add those together, we get 94 equals x. And x is, of course, the measure of JKL, and that is my final answer. The measure of angle JKL equals 94 degrees. And 94 degrees is an obtuse angle. So my picture, it doesn't look like it's obtuse. So my picture isn't very accurate as far as to scale, but that's okay. I didn't know what it was until I was done with the problem. All right, so let's talk about a little bit more definition. If two angle measures are equal, so if there's two angles, angle A and angle B, and they're the same size, right? They're the same size. First of all, we can show that by putting little arcs in there. You can put the little arcs in there. That tells you that these two angles have the same size. Now, we'd write the statement, the measure of angle A equals the measure of angle B. Whatever that measure happens to be, 30 degrees, 40 degrees, they're the same, okay? If A is 30, B is 30. If A is 40, B is 40 degrees. We can also say that the angles then are congruent. So remember that distinction from our last class. If you're talking about numbers, if you're talking about values, so like the measure of angle A, we use the word equal when we're talking about values. Now that we're in geometry class, if we're talking about a figure or a shape that's the same, we don't say the shapes are equal. We say the shapes are congruent. And again, the symbol looks very similar. It's an equal sign, a little tilde above it. The last definition here we're going to talk about is an angle bisector. An angle bisector is a ray that divides an angle into two congruent angles. Okay, so right there. So BD, ray BD is an angle bisector because notice it cuts the angle into two equal pieces. How do I know that they're equal? The arcs, right? So when you're drawing an angle bisector, which our next problems are going to be, we draw it right down the middle, but how do we know it's right down the middle? We need to draw the arcs in there to tell the person looking at the picture that that is an angle bisector. It breaks the angle into two equal pieces. All right, so GJ bisects angle FGH. Okay, let's start with drawing that. So first, again, I always start by drawing the angle. So we have angle FGH and GJ is an angle bisector. So not only do I draw it down the middle, I put the arcs in there. So that tells the person that that's going right down the middle. The measure of angle FGJ is 12 degrees. That's 12 degrees. Find the measure of angle JGH, it's the bottom one. Find the whole thing. All right. Well, the measure of JGH, since I see that these two are congruent, if the top one's 12, this one down here has to be 12, right? So that's one of my angles. The measure of angle JGH equals 12 degrees. And then to find the whole thing, right, we can use the angle addition postulate. The part plus the part equals the whole. The part plus the part equals the whole. So we have 12 plus 12 equals x. 12 plus 12 is 24 equals x. So then the measure of the whole thing, angle FGH, equals 24 degrees. ray LN bisects angle KLM. The measure of angle KLM is 48 degrees. Find KLN and the measure of NLM. All right, so let's draw that first. So KLM. KLM. LN bisects it, and I show that by putting the arcs in there. Okay, now it says KLM. KLM, that's the whole thing, is 84. I need to find these two I don't know. So I'll call this X, and since these two have to be the same, I can call this one X as well. And I'm actually going to use the angle addition postulate here. The part plus the part equals the whole. The part plus the part equals the whole. So I have X plus X equals 84. So now we got to think back to algebra, right? We're not done using algebra here in geometry. So what's X plus X is 2 X's equals 84. Solve for X, divide by 2. X equals 42. All right, so and that's what X equals, and that's what each of these equals, 42 and 42. So the measure of angle KLM equals 42 degrees, and the measure of angle NLM equals 42 degrees. Our last two problems here, I'm just going to pop them both up. See if you can use your notebook here. See if you can draw accurate pictures of these angle bisectors and correctly solve the problems. And then hit play and check your work. All right. So angle A, B, C, B, D is an angle bisector. And did you put the arcs in your picture? Remember, we need to do that to be accurate. The measure of DBC, that's the bottom, is 36. And then find the other two. All right, well, ABD, the top one, right? These have to be the same because it's an angle bisector. So I know this one has to be 36 as well. And so that's one of my answers. The measure of angle ABD equals 36 degrees. And then to find the whole thing, we use the angle addition postulate. The part plus the part equals the whole. So 36 plus 36 equals X. So add those together, I get 72 equals X. And so the other answer, the measure of angle ABC equals 72 degrees. All right. Last example here. Ray QS bisects angle PQR. The measure of PQR equals 42 degrees. Find the measure of PQS and the measure of SQR. So let's draw the picture first. PQR. So P, Q, and R. And QS bisects it. QS. And we put the arcs in there. All right, so the measure of PQR is 42 degrees. And then we got to find these other two, PQS, the top one, and SQR, the bottom one. And again, I'm just going to put X's in there because they're the same. I can use X for both of them. And then we have the part plus the part equals the whole. X plus X equals 42. 2X's equals 42. Divide by 2. X equals 21. So our answer, the measure of angle PQS equals 21 degrees. Measure of angle SQR equals 21 degrees. And then again, we always end with an epilogue question, epilogue day 2. So find the measure of the angle formed by the hands of a clock. And it should say that it is when it is. That's what it should be. When it is. All right. All right, epilogue day 2. Find the measure of the angle formed by the hands of a clock when it is 7 o'clock. Like a little hint there, a full circle is 360 degrees. So take a second, pause the video, see if you can figure out this answer, then hit play and check your work. All right, so I think the easiest way to do this is actually kind of start maybe by sketching out a clock. Instead of sketching it, I'm just going to make a clock up here because that's a little easier for me. So it tells us that the whole thing is 360 degrees all the way around. That's what a full turn is, a full circle. So for us, and it's broken into 12 pieces, right? So like here's one piece, right? If you think about it like that. And what I can do, and there's 12 of those all the way around the clock, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So I can figure out what this is by taking 360 and dividing by 12. And if I do that, I get, this is 30 degrees. And then, how many 30 degrees are there in this angle, right? There's 1, 2, 3, 4, and 5. And so you can do 5 times 30 and you get 150 degrees, which is A. And again, we do have an epilogue quiz in the Schoology class, and the answer to that is A, and that's where you start and then continue on with the problem set. If you have any questions, swing by the live help sessions on Google Meet. Otherwise, I'll see you next lesson. Ciao.